Okay, so I'm guessing that these are the division problems that you were talking about. There's three of them. Number 23 there says use synthetic division. We're not going to use synthetic division. We don't have to do that, but I will show you one more long division problem because you can do number 23 with long division as well. So looking at number 21, I want you to notice that 4x squared, like that's one term, as opposed to like 22 and 23 that both have two terms, so they've got two pieces. So problems like 21, they set up a lot easier in the sense that I just get to take the numerator and give that denominator to each piece of the numerator, and then I've got all these smaller fractions that we can just simplify, right? So 24 over 4 reduces to 6, and that's a 6 on top. We'll have to see if we have a denominator or not, but that's a 6 on top. X cubed on top, x squared on bottom, leaves me with x cubed on top. So 5 minus 2 gives me 3 on top, all right? Minus 12 over 4 reduces to 3, and then the x squared cancels, like it just goes away. X squared over x squared, 2 minus 2 is 0, so x to the 0 is just 1, so the x squareds disappear. Oh, something funny happened. All right, 4x over, so the 4 over 4 is 1. But then this is interesting because we've got two x's on bottom and only one x on top. So then we would have one x left on bottom. Okay, and so that's number 21. All right, 22, we'll actually work that like a division problem. So let me get some stuff out of the way here. Sorry about all the tapping. So here we go. 5x cubed plus 18x squared plus 8x minus 3. Now I do want you to notice that nothing is missing, and by that I mean we have x cubed, x squared, x to the first, and then no x, right? So if one of those things had been missing, we would have had to have done something else. We would have had to add a placeholder. We talked about it in class. Everything is there, and so we don't have to add any placeholders. So there's our numerator divided by x plus 3. Okay, so here's the question. X times what gives me 5x cubed, 5x squared. Okay, now all of this, and I'm going to erase this in a second, but all of this gets multiplied right here, and then it goes under here, and that's when we do our subtraction. Okay, so 5x squared times x, 5x cubed, that's got to match. It does, so we're good. 5x squared times 3 is 15x squared, and then the whole thing gets subtracted. So 5 minus 5 cancels. 18 minus 15 is 3x squareds. Drop the next piece down, plus 8x. Okay, so now x times what gets me 3x squared? 3x. Okay, so again, this is going to multiply here, and then we'll move it down here, and that's when we do our subtraction. So 3x times x, 3x times x is 3x squared. 3x times 3 is plus 9x. All of that gets subtracted, right? 3x squared minus 3x squared, that went away. That's what we needed to happen. 8x minus 9x is there's negative x. Drop the minus 3 down. And then what times x gets me, just happened? Oh, there it is. So x times what gives me negative x, and that's going to be a negative 1. So negative 1 times x is negative x minus 3. And that's zeroed out, and so we're good. If we'd had a remainder, that remainder would have went up here over the x plus 3. We didn't have a remainder, so we're good. Okay, so this is our final answer. Okay, so again, 23 said synthetic division. We're not interested in doing synthetic division right now. So let's take our numerator, 3x cubed plus 7x squared minus 2x minus 2 divided by x plus 3. I'm going to go a little quicker here. So x times what? 3x squared. All right, because then I'm gonna multiply here. Okay, so 3x cubed plus 9x squared. We're going to subtract. So that leaves us with negative 2x squared minus 2x. So next piece would be minus 2x. Again, we're going to multiply it down and get negative 2x squared minus 6x. Then we're going to subtract. And we're going to get 4x. Drop the next piece down, minus 2. We'll have a remainder this time. So plus 4 would give us 4x plus 12. All that's going to be subtracted. So we're going to have negative 14. And that negative 14 goes on top of our divisor out there. And then this would be our final answer.